is constructed for the purpose to import and export the liquids, gas, and they decide to make the new factory to contain and refine the liquids, gas.
Because this is the new port, so every 5 years they have to do the verification and inspection to check the condition of the port as a requirement of the government. So later on, with the new technology of laser scanning, we can compare what is the difference between 5 years. Laser scanning is not a new technology on the world, but it's very new in Vietnam. We Portcos are the pioneer in developing the laser scanning technologies in collecting the data and building the 3D model for the ports in Vietnam.
The challenges that we have to deal with is in the real construction. When we apply the scanner technique in this area, this is ongoing. A lot of equipment like vehicle, truck, the moving equipment is affected to the selection of a scanning point. And secondly, it's in the LPG port. So a lot of steel structure is affected to the signal of GPS.
When we do the scanning for the Hyosung project, we always have problem with the narrow area between the pipeline. The distance between them only 20 cm, and sometimes they have to go underground. So it's quite complicated area, and with the capability of combining the station, the Leica RTC 360 and the Leica BOK 360 help us a lot in developing the 3D point cloud model for the Hyosung project.
In this port, it's a sensitivity structure, especially for the sediment, deformation, and so on. That's why we need to use the equipment, the measurement equipment with very high accuracy. Based on the scope of work, we use 3D laser scanner combined with several software to checking the displacement of the pyrite, the pipeline system, and also the revetment. Based on the point cloud data, using the 3DR software, we make the contour line and also the cross section at the different station of the revetment. And based on this data, we combine with the design one. The difference between the real scanned data and the design drawing will be used to determine the displacement of the revetment.
After the data is collected from the field from the Leica laser scanner, we post-processing the data using the Leica Cyclone, and the results will be the 3D point cloud model. And the 3D point cloud model will be handed over to the employer as a base to develop the next step, the 3D modeling and the beam model.
Currently, we are using the BOK 316, RTC 316, and finally P15 combined with the other geomatic system from Leica like TS16, Icon 18, using a Cyclone register and Cyclone register 316. Based on this data, we can apply the VR technique and also the AR technique to create a virtual object. And based on the point cloud, we can create the S-view drawing, S-view model. We can determine the segment, the bending of the concrete beam, the displacement of the concrete pipe, and also the flatness of the concrete slab.
For the total station and the GNSS equipment, we use it to define coordinates and elevation of each station, so that when we combine the data from the laser scanner, each point will have the coordinate and elevation and color data.
The process data is dependent on your software and also your skill, right? In this case, like the software of Leica is very good to show it. The time efficiency is very important. It's not only for working on the field, but also for processing data Why we say about the efficiency of Leica is the time processing of the software. For example, using the different scanner, we take around 1 day, but currently using the Leica equipment, we take around 2 hours.
We are very happy that we choose to use the Leica equipment to apply into our laser scanning project because of their reliability and high accuracy and durability when you use this on field.